So if you work at a mid-sized company with, say, 1,000 employees, your HR department is actually missing about 45,000 people from their payroll.
Yeah, quite a few missing bodies there.
Right. I
Yeah.
mean, these missing employees, they never take a vacation, they never get a paycheck, no health insurance. But, and this is the crazy part, they hold the absolute highest level of security clearance in your entire network.
Which is terrifying when you really think about it.
It is. Today, we are looking at this massive, mostly invisible blind spot in modern cybersecurity because, you, me, the CEO, we are not the majority of the workforce anymore, not even close. We are outnumbered 45-1 by machines.
Exactly. And it forces us to completely reevaluate what a corporate network actually looks like today. I mean, we spend so much time and money building these massive fortresses around our human employees, and we just kind of completely ignore this sprawling city of automation running right beneath them.
Which perfectly brings us to the mission for this deep dive.
Yeah.
Today, we are unpacking a really fascinating source document titled, Since When Does a Bot Have an Identity.pdf?
Great title, honestly.
It really is. So we're going to explore the critical differences between human and non-human identities, dig into the mechanics of this terrifying reality called identity sprawl, and figure out how organizations can actually put a leash on these autonomous AI bots and service accounts. So, okay, let's unpack this. What exactly is the core difference we're looking at here?
Yeah, so the document provides a really brilliant visual framework to anchor this whole concept. Think of two distinct profiles, right?
Okay.
On one side, you have a human. Let's just call him John. John represents the WHO, like who you are. His access to the company network is secured by things that are intrinsically tied to him as a person.
Like a password.
Exactly. It relies on what he knows, like a complex password, or what he has, like, a multi-factor authentication app on his smartphone.
The classic push notification.
Right. Or even what he is physically, using biometrics like Face ID or a fingerprint scan.
So John is very tangible. I mean, he has a manager, a department, a physical desk, and most importantly, he belongs to an HR system that, tracks his employment status.
Spot on. Now, contrast that with the other side of the visual, a piece of software, a non-human identity, or NHI.
NHI, got it.
Right, NHI. So if humans are the WHO, NHIs are the what? This is what your code uses to talk to other code. Machines obviously do not have fingerprints.
Unfortunately.
Yeah. And you can't exactly send a push notification to a server and ask it to, approve a login attempt.
That would be a very long wait.
Exactly.
Yeah.
So instead, non-human identities are secured by cryptographic keys, automated rotation policies, digital vaulting, expiration dates.
Right.
They authenticate using these incredibly long, complex strings of characters that essentially act as their proof of existence.
So before we get into the actual cybersecurity risks of all this, I have to bring up the philosophical elephant in the room here.
Go for it.
Because when I first read this document, I found myself just getting kind of hung up on the terminology. Why are we calling this an identity at all? I mean, identity implies personhood.
The natural reaction.
It implies someone with a birth date, privacy rights under laws like GDPR, maybe a social security number. Giving a piece of code an identity just feels like this strange anthropomorphism to me.
That specific philosophical hurdle actually confused the entire identity and access management industry for about 2 decades.
Really?
Oh, yeah. We have to violently separate the concept of a legal identity from a technical identity.
Okay, break that down for me.
Well, a legal identity is exactly what you just described. It involves PII, personally identifiable information. It can sign an employment contract. It can get sued in court.
The living, breathing participant in society?
Right. But a technical identity operates on an entirely different plane. According to the official NIST definition, that's the National Institute of Standards and Technology, an identity is simply any entity that can be authenticated and authorized to access a resource.
So it doesn't have to be human.
Not at all. It doesn't need a soul. It only needs the ability to walk up to a digital door, present a secret token, and request a packet of data. If it can do that, the system needs a record of it. And what's fascinating here is how the definition of that digital entity has evolved.
Right, the document goes into that.
Yeah, it traces this evolution through 4 distinct eras.
I really want to dig into that timeline, actually, because it illustrates so well how the machine kind of grew up,
Right.
from a simple tool into an autonomous worker. Take us back to the beginning.
Okay, so let's look at the 1970s through the late 1990s. Back then, we basically just had service accounts.
Which are what, exactly?
Imagine a simple, bash script written by a system administrator just to back up a database every night at midnight. That script used a shared username and password, and they often hard-coded it right into the text of the script itself.
Ouch.
Yeah, terrible security practice today, but back then, nobody thought of it as an identity. It was just a dumb, rigid tool doing a chore. It was totally ungoverned.
It was like a digital broom sweeping the floor.
Perfect analogy.
Uh-huh.
But then the 2010s arrived, and with it, the cloud explosion.
Right. Amazon Web Services, Azure, all of that.
Exactly. Companies migrated massive amounts of infrastructure to the cloud. And suddenly, software architecture completely changed. We started using containers, these lightweight, packaged pieces of software and microservices.
Okay, so how does that change the identity piece?
Well, imagine you have a container whose only job is to process payments. That container needs to authenticate to a separate database container on its own, thousands of times a second.
Wow. Okay.
So AWS introduced IAM roles to handle this. These containers were given permissions, policies, and the ability to temporarily assume other roles. They started looking and acting very much like human users in a directory.
Just operating at machine speed.
Exactly.
But we still weren't calling them identities at that point in the 2010s, were we?
No, not really. Not until around 2020. That is when the term non-human identity was officially cemented by organizations like Gartner and specialized security firms.
Why the shift in 2020?
Companies suddenly realized they had 1,000 human employees, but 50,000 of these digital entities, all holding high-level access keys. They were way too powerful to just be called accounts anymore. They required governance frameworks similar to actual human identities.
Which brings us to the present day and the era of autonomous AI agents. And honestly, here is where my old toaster analogy just falls apart.
Yeah, the toaster doesn't really cut it anymore.
No, an old school bot from the 90s was a rigid set of instructions, right? You push a button, it makes toast. If X happens, do Y. But these new AI bots are entirely different. It feels less like buying a toaster and more like, I don't know, hiring a personal assistant, handing them a corporate credit card, and giving them a master set of keys to the office building.
The document explicitly highlights this shift. It's a huge deal. An AI agent is fundamentally different from a traditional automation script because it operates probabilistically, not deterministically.
Meaning it kind of thinks for itself?
Right? It has memory. It has the autonomy to choose which tools it needs to use to accomplish a really vague goal.
Give me an example of that.
Say you ask an AI agent to resolve this customer support ticket. To do that, the agent might decide completely on its own to log into your corporate email, read the thread, check a bug tracker in Jira, pull a billing record from Salesforce, and then access your cloud infrastructure to restart a server.
That is wild. Its behavior changes dynamically based on the task it decides to execute.
Exactly. And because of that autonomy, you cannot secure it with a single static API key tied to one specific database. It needs dynamic access.
Right.
It essentially needs an employee badge with a designated role, a department, a manager, and a behavioral baseline. Because if AI agents are acting with human-like autonomy across multiple systems, they mandate human-like governance.
So what does this all mean? I mean, we understand the philosophical shift now. We're treating pieces of code as identities because they make autonomous decisions and access critical data. But now we need to look at the sheer scale of the problem.
The scale is the scariest part.
Right. If you're listening and you manage a network right now, you might think you have a handle on your workforce. But let's go back to those staggering numbers from the source document. A ratio of 1 human to 45 non-human identities.
Yeah, so a mid-sized organization of 1,000 humans is managing between 20,000 and 50,000 non-human identities.
That's just incomprehensible.
It is. And to understand how that even happens, we have to break down what those thousands of identities actually are. The document categorizes them into two main building blocks: workloads and secrets.
Okay, let's define the mechanics of those two blocks.
Sure. So the workload is the entity itself. It is the thing doing the work. This could be a legacy service account, a modern microservice, a cloud resource, or even the automated CI/CD pipelines that developers use to push new code into production.
Got it. And the secrets are basically the currency those workloads use to move around the network.
Exactly. The secrets are how the workloads prove their identity to other systems. These take the form of API keys, security tokens, SSH keys, or digital certificates.
It's the machine equivalent of a password.
Precisely.
And this brings us to the lifecycle problem, which honestly is where the nightmare really begins in this document. Let's compare how a company manages the human life cycle versus the bot life cycle.
It's a night and day difference.
Because for humans, the process is incredibly mature, right? We rely on the HR department and the whole joiner, mover, leaver process.
Right.
You join a company, IT provisions your access based on your role. If you move from marketing to sales, your access is adjusted.
And most importantly, the lever phase is immediate.
Yes. When an employee quits or gets fired, HR updates a centralized directory, and within seconds, that person's access is disabled across every single application they used. They hand over their physical badge, and their digital badge is revoked. It's a clean break.
But there is no HR department for bots. If a developer needs to spin up a new non-human identity to test a feature, they don't submit a requisition form to HR and wait 2 weeks.
Of course not.
They type a quick command in their terminal, like, Ausim create role, and boom, the bot exists. They generate a secret key for it. And because developers are under immense pressure to move fast, they might just hard code that secret key directly into the software's source code,
Oh boy.
or drop it in a random configuration file, or leave it in a GitHub repository.
And that speed of creation without any centralized tracking is the core issue here. I mean, the source document notes that 90% of these non-human identities are completely invisible to a company's identity and access management teams.
90%.
Security doesn't even know they exist.
Right.
Wait, so if these bots are invisible and untracked, that means when the developer who created them leaves the company for a new job, the bots just stay behind.
Yep, like phantom employees.
That's so creepy. So the human's access is revoked by HR, but the 50 bots they spun up for a project 3 years ago are still just wandering the digital hallways holding master keys to the database.
Exactly. The industry terms this NHI Sprawl. You have a massive, completely undocumented workforce of immortal bots that never retire, they never change their passwords, and they are never audited.
Immortal bots.
And this sprawl is exactly why attackers have completely changed their tactics.
Okay, let's talk about those attackers. Because theory is one thing, but how are hackers actively exploiting this invisible workforce? I mean, we typically think of hacking as tricking a human. You send a phishing email, or you use MFA fatigue, right?
Right. Spamming an employee's phone with login approval requests until they get annoyed and just hit approve to make it stop buzzing.
Exactly.
But defenders have built excellent countermeasures against human error now. We use conditional access policies, we restrict logins to managed devices, and we analyze user behavior.
So the human front is pretty fortified.
It is. And attackers are businessmen. They look for the path of least resistance. Why spend weeks trying to trick an executive who has hardware-backed multi-factor authentication when you could just find a bot's forgotten secret key?
Because the bot doesn't have MFA.
Exactly. Non-human identities are compromised not by trickery, but by discovery.
Discovery.
Hackers literally scrape public and private Git repositories looking for leaked secrets. They search through old Slack channels. They execute supply chain attacks to pull API keys out of unencrypted configuration files.
Man, it changes the analogy entirely. A human identity is like this heavily guarded front door with a smart lock, security camera, a guard dog, and attackers are looking at that front door and just walking away.
Why bother?
Right. Instead, they're just wandering around the property picking up one of the 50,000 spare keys we've hidden under rocks, in the bushes, and under the doormat. And we never bother to change the locks on those doors.
The document calls out a specific, terrifying concept here. The forever key.
The forever key.
Yeah. We force human employees to change their passwords every 90 days, right? We force them to re-authenticate every morning. But because organizations lack visibility into their non-human identities, they're terrified of breaking production systems.
Because they don't know what the bot actually does.
Exactly. So they never enforce expiration dates on API keys. An API key created by a developer back in 2021 is likely still completely valid today.
A stolen token is valid forever.
Ever.
If an attacker finds an old API key sitting on a neglected server, they are instantly inside the network with whatever privileges that key holds.
And the damage rarely stops at that initial point of entry. It triggers a domino effect known as lateral movement.
Okay, walk us through the mechanics of a typical breach using this.
Sure. Let's say an attacker finds a leaked SSH key in a developer's .env file. That single key grants them access to a minor container running some mundane task.
Okay, nothing too critical yet.
Right, but that container needs to pull database credentials to function, so it has its own identity token to access a centralized secrets vault. The attacker masquerades as the container, presents the token to the vault, and extracts the database credentials. From there, they escalate privileges and compromise the entire cloud infrastructure.
Dominoes, which explains a very alarming statistic from the source document. In the OWASP Top 10, which is the definitive industry list of the most critical security risks, non-human identities are now ranked as the #1 attack vector for CI/CD environments.
Number one, hackers are exclusively targeting the bots that build and deploy code.
Because compromising the CI/CD pipeline gives an attacker the ability to inject malicious code directly into the software a company ships to its own customers.
It is the ultimate prize, and NHIs are the easiest way in.
Okay, if you are listening to this and you manage any sort of infrastructure, panic is probably setting in right about now.
Understandably.
We are talking about thousands of invisible, immortal bots with permanent keys that hackers are actively hunting. So we need to shift to solutions. How does an organization actually clean up a mess of this magnitude? I mean, you can't just unplug the machines.
No, you definitely can't. But leading security teams and pioneers in the space have developed a specific methodology for this, which the source outlines as a comprehensive non-human identity security program.
Okay, let's go through it.
It's essentially about building that missing HR department for your code. And the foundational step is discovery. You cannot protect what you cannot see.
So you have to sweep the property to find all the spare keys under the rock.
Exactly. Organizations deploy specialized scanning tools that integrate directly into their environments. GitHub, AWS, Jenkins, Kubernetes clusters, all of it.
Just spanning for everything.
Right. These tools parse through millions of lines of code and configuration files looking for the distinct patterns of API keys, tokens, and service accounts. And once you find them, you move to the inventory and classification phase.
Okay, inventory.
Every single non-human identity must be cataloged with the same context as a human.
See, this is where my instinct as a security admin would be to just start deleting anything that looks old or undocumented.
Do not do that.
I'm guessing that is a fantastic way to accidentally take down the company's entire payment processing gateway.
Arbitrary deletion will cause catastrophic outages.
Right.
Before you revoke anything, you have to assign context. What application does this key support? What environment is it running in? And crucially, it needs an expiration date and a human owner.
A human owner.
We will explore the philosophy of ownership in a minute because it is the linchpin of the whole system. But once you have an inventory, you have to secure the credentials themselves through vaulting and rotation.
Meaning we get the secrets out of the raw code, like developers can no longer hard code passwords into their scripts.
Exactly. The secrets are moved into a centralized, encrypted secrets manager. The application is rewritten to request the key dynamically when it needs it, rather than storing it locally forever.
Okay, that makes sense.
Furthermore, you eliminate long-lived API keys entirely. The system enforces the use of short-lived tokens.
But wait, if I force a piece of software to rotate its key every single hour, doesn't that create a massive computational overhead? Like, what happens if the application fails to fetch the new key in time? Doesn't that risk breaking the app?
That's a common fear, but it requires a robust, automated infrastructure, which is why organizations use dedicated identity providers and standards like OIDC, or OpenID Connect, for machines.
Okay.
The rotation happens seamlessly at the protocol level. The security benefit vastly outweighs the engineering effort. Think about it. If a machine requests a token that is only valid for 1 hour, and a hacker manages to steal that token from memory,
The token becomes useless before the hacker even has time to figure out what system it belongs to.
exactly. It significantly shrinks the window of opportunity.
Okay, so once the keys are rotating, how do we limit what the bots can actually do?
Through the principle of least privilege. The source document notes an incredible statistic here. Most containers and cloud roles are overprivileged by 80%.
80%.
Yes. When developers spin up a bot, they often grant it broad, sweeping access like read-write to all databases, just to ensure it works without friction.
Just to get the job done fast.
Right. So security teams must continuously analyze the actual usage of the bot and strip away any permissions it hasn't actively used. If a bot only needs to read a single table to make toast, you revoke its access to everything else in the kitchen.
Okay, that covers privileges. But what about detecting when a bot gets hijacked anyway? Because even a short-lived token with least privilege can do damage in the wrong hands.
Well, if we connect this to the bigger picture, we monitor human employees constantly using user behavior analytics.
UEBA.
Right. If you normally log into your workstation from an office in New York at 9 a.m. and suddenly your account attempts to download a terabyte of customer data from an IP address in Russia at midnight.
The system freaks out.
The security system detects the anomaly and locks you out instantly. Bots require the exact same behavioral baselining.
Anomaly detection for machines.
Yes. If a service account is programmed to simply read configuration data from a server in the US during business hours, and it suddenly attempts to delete cloud infrastructure in Europe on a Sunday morning,
Red flags everywhere.
the monitoring system must recognize that deviation from the baseline and instantly kill the bot's session.
Wow. Okay, so to recap, discover the sprawling keys, build an inventory, enforce short-lived vaulting, strip away excess privileges, and monitor behavior. It is a massive undertaking.
Huge.
But I want to circle back to the classification phase, specifically the concept of ownership that you brought up, because the author of the source document lands on a distinction that I honestly think is the most profound takeaway of this entire deep dive. It's the fundamental difference between a human and a non-human identity.
Yes, it's so important. A human owns an identity. A non-human is owned by an identity.
The 2 a.m. test. Explain the mechanics of this, because this is where the theory actually hits reality.
Okay, so non-human identities do not have personal information. They are not people. But they must be inextricably tied to a real, living, breathing human being within the organization.
Right.
Imagine it is 2 a.m. on a Saturday. The Security Operations Center systems start flashing red. A legacy service account named SVC Payments Fraud is suddenly exfiltrating massive amounts of sensitive customer data to an external server.
That is a total nightmare scenario for any incident responder.
Exactly, and you cannot call the bot. The bot is not going to answer the phone and explain why it is behaving erratically.
Obvious.
So you need a human owner field attached to that bot's identity record in your centralized inventory. Just like employee John Doe has a tag identifying his manager in HR, that payment bot needs a tag that says, owned by lead engineer Sarah.
So when the alarms go off at 2 a.m., the security team knows exactly who to call to determine if this is just, a scheduled maintenance task gone wrong or an active breach.
Precisely. The ultimate security control for non-human identities is not a line of code or a complex cryptographic algorithm. It is human accountability.
Human accountability.
We do not call bots identities to bestow rights upon them. We call them identities to force ourselves to govern them with the exact same rigor, strict limits, and human accountability that we apply to any flesh and blood employee holding keys to the company vault.
So treating bots as identities is really about forcing organizations to take responsibility for the automation they build.
Exactly.
It means looking at this invisible, sprawling workforce of 50,000 machines and finally asking, who hired you? What exactly are you allowed to touch? And when does your contract expire?
It brings necessary law and order to the Wild West of modern cloud architecture.
It really does. So if you've been listening, you now understand why the cybersecurity world is frantically shifting its focus toward non-human identities. You know why the machines outnumber us, how attackers are exploiting forgotten secrets in .env files to bypass our heavily guarded front doors, and how organizations must build an entirely new framework to manage the life cycle of their code.
It's a whole new world.
But I want to leave you with one final provocative thought. Something for you to mull over that builds naturally on what we discussed regarding these new autonomous AI agents. The source document noted that modern AI agents have the autonomy to choose their own tools, adapt their behavior, and figure out the best way to accomplish a goal.
Right.
So consider what happens tomorrow. What happens when an AI agent decides completely on its own that it needs to spin up its own non-human identities to accomplish a task?
Oh, wow.
Think about it. An AI generating new bots, creating new secret keys, assigning permissions, all entirely autonomously with zero human developers in the loop. The machine creating its own invisible, undocumented workforce.
That's entirely possible.
If an AI creates an identity, and that child identity goes rogue, who do you call at 2 a.m. then? Think about the mechanics of that the next time you hear a company announce they are replacing their workflows with autonomous agents. Thank you so much for joining us on this deep dive. Keep questioning the systems around you, and we will catch you next time.